Hello students, welcome to my channel Concept Tech 2018. I am Sunanda Manke and this is the series on online electronics laboratory, and this is the part where we'll discuss the lab exercises on filters. Filters are basically circuits which are capable of passing signals with certain frequencies and reject the other frequencies, and this property of filters is called its selectivity. And the frequency response of the filter, basically it's a graph between the voltage gain and the frequency, and with the help of this graph we can differentiate between different filters. The filters are used to separate desired signals from undesired signals. They are used to block interfering signals. They are used for enhancing speech and video signals, and they are also used to vary the or to alter the signals in some other ways, like we can alter the phase or we can introduce delay for the given input frequency with the help of filters. The classification of filters, based on the components which are used in the filters, we have active and passive filters, and based on the frequency we have high pass, low pass, band stop and all pass filters. Passive filters use passive component, that is they use resistor, inductor and capacitor, whereas in active filters we use the active component like amplifiers. Operational amplifier is used with passive components, that is R and C. In the filter, the active devices are used for providing voltage gain. Op-amp provides the gain, and the RC circuit, which is the passive circuit, that is used to provide frequency selectivity. The active filters are normally used below 1 MHz and passive filters are used for high frequencies. Active filters are easy to tune compared to passive filters. This gives the ideal response for the four filters. We have low pass filters which passes low frequencies, attenuates high frequencies. High pass filter attenuates low frequencies, passes high frequencies. Band pass filter passes a specific band of frequencies, and band reject filter rejects or blocks a specific band of frequency. So we have pass band and stop band. The frequency in the pass band are passed through the capacitor, and frequency in the stop band are stopped, blocked or attenuated by the given filter. The assignment includes passive filters and active filters. Passive filters, as discussed, have R, L and C components, whereas in active filters we have operational amplifier with R and C components, resistance and capacitance. Coming to active filters, in active filters we have first order low pass high pass filter, second order low pass filter, Butterworth high pass filter and Chebyshev low pass filters. We'll do all these experiments. And here what do we mean by the order of the filter? Basically, order of the filter depends on the number of RC circuits which are connected in the filters, and the filter response improves as the order of the filters increases. That is, if we have one pair of R and C, then it is a first order filter. If we have two resistors and two capacitors, the filter order becomes 2. So as we go on increasing the number of RC circuits in the filter response improves. Let us do the experiment on first order active filter. We'll use virtual lab for this filter, and we'll observe the response of low pass as well as high pass circuits. Let's do the experiment on active filters. We are at Analog Electronic Circuits lab, and we'll do the experiment on active filters. Again, we have the page here showing the objective. So objective is to do active low pass, high pass and band pass filter. We can check the procedure and the theory. The theory gives us the filter circuits here, right? The procedure gives us the connections to be made, the details of the connection, details of the values of the components to be set. We'll go to simulation and we'll go to low pass filter first, active low pass filter. In the previous experiment, we have done experiment with passive filter. In active filters, we use operational amplifier with resistor and capacitor. It's a first order filter, so we have only one capacitor here. So as per the instructions given, we'll do all the connections, and once the connections are made, we'll set the component values and check the output as before. In the instruction part, we can check the connections and then we can do all the connections as per the instructions given. We have to do the connections carefully so that the experiment can be performed. We are checking the connections in the instruction pan and we are doing all the connections. Now we'll check the connections. Connections are right. Now we have to set the component values. R1, RF are to be set at 10 kilo ohms. So we'll set the value of R1. It is set to 10 kilo ohms. Now we'll set the value of RF to 10 kilo ohms. R is to be set to 15 kilo ohms. So we'll set R to 15 kilo ohms. This is the R value. It is set to 15 kilo ohms. The last setting is for the capacitor, which is to be set to 0.01 microfarad. So we are setting it to 0.01 microfarad. Input voltage as before is to be set to 10 volts. We are increasing the input value to 10 volts and we'll change the frequency from 50 Hertz to the maximum value possible in this lab. We'll start with 50 Hertz and we'll add the entry to the table. As before, it's a low pass filter. We'll observe output here for the given input. As soon we click on add to table, we get the output. The output is 20 volts. Now we'll increase the frequency and we'll add it to the table. Still 20 volts, low pass filter, so output will be maximum for the low frequencies. Let's increase the input frequency further. Add the entry to the table for 100 Hertz. It is reducing now. It is 19 volts. It has come down to 19 volts from 20 volts. 144 Hertz. Let's go further. You can observe the frequency and the voltage is reducing. Approximately 500 Hertz input. Output is 17. Increasing further, reduction in the output because it's a low pass filter. As we increase the frequency, the output amplitude reduces. It attenuates high frequencies and passes low frequencies, and the cutoff is decided by the circuit components. So we have taken 10 entries here. Now we'll do the plotting. We'll see the frequency response. We are interested in the frequency response. And you can observe the frequency response for low pass filter. As we are increasing the frequency from 0 to 2K, the amplitude is reducing. So it's a first order low pass filter. Let's do the experiment for high pass filter now, active high pass filter. This filter also contains one operational amplifier, one resistor and one capacitor. Position of capacitor and resistor is interchanged in high pass filter as we did with passive filter also. We'll do the connections again and we'll check the output for the given input. So first of all, we have to do the connections, then we have to set the component values, and then we have to give the input and check the output. It's a high pass filter. So for low frequencies, output will be low. As we go on increasing the frequency, output amplitude will increase. The advantage with active filters is we get gain at the output compared to passive filters, where the output signal is having lesser amplitude compared to the input signal. All the connections are made, connections are right. Let us set the values of the resistances. R1 10K, RF 10K, then resistance R. It is to be set to 15K. Last is the setting for the capacitor, 0.01 microfarad. Now we have to apply the input signal and observe the output signal. We'll give 10 volts input and we'll go on changing the input frequency. Being active high pass filter, we'll observe the output for low and high frequencies. Let's add the entry to the table and you can observe the output amplitude is very small. As we go on increasing the frequencies, we are expecting a high value at the output, and the output amplitude is slightly increased from 1 to 2, and it is increased to 4 volts and 6 volts as we are increasing the frequency, 9, 13 and 16 volts. So we are obtaining gain at the output. The input amplitude is 10 volts and output obtained is greater than 10 volts as this is a active filter. So with increase in frequency, output amplitude is increasing. Now we'll plot it. We'll observe the frequency response for this filter. And being high pass filter, as we increase the frequency, the amplitude is increasing. This is how high pass filter works. I hope you have understood how active filter works. Thank you.